Well, I hear you on the bell ringer, so let's just go ahead and get it out of the way. If you thought the answer to the bell ringer was B, you're incorrect. And we need to talk about why and why this is a challenging problem. So,
Don't you have to like
yeah, we got to work on that. So, if you thought you were supposed to do 8 times 12 and get 96, and I'm frozen. You do understand how to convert between inches and feet. I'll give you that much. You understand that. However, this problem is not in feet. If you read it carefully, it says a key word of cubic. What does the word cubic mean? Cubed. It means, so instead of just having 8 feet, we actually have 8 feet cubed. So if we're wanting to convert to just normal feet, we're going to have to get rid of the cube. How do you get rid of a cube?
8 times 8 times 8.
Well, 8 cubed is 8 times 8 times 8, but how do we undo a cube? Square root would undo a squared. That's true. How do we undo a cube? Cube root. We're going to have to take the cube root of 8, which sounds crazy, but it's going to end up being a nice, pretty number. If you happen to know that off the top of your head, that's great. If not, and you have one of my calculators, I'll show you how to type it in now. Do you see the button that has an arrow on it? If you press the second button and then the purple above it, let me see if I can zoom in close enough. I doubt I can. Oh, it's too blurry. There's the square root. You can kind of see it. And then above it is like whatever root you want. And we want cube root. So we're going to press 3. Then the second root button. But make sure you're not doing the square root. Make sure you're doing the one above the square root. And then you'll press 8. And it will tell you the answer. So if we wanted, for instance, the cube root of 27, we would say 3. Weird button, 27. And it would tell us the answer. So if you're ever asked to do a weird root, your calculator can do it for you. Although they do think that you're supposed to know 2 to the third is 8. So the cube root of 8 is 2. That is something people would try to argue that you're supposed to know. Okay, so we've undone the cube, and now we're just to normal feet. We've undone the cube. So since we've undone the cube, we can convert from feet to inches. Well, multiply by 12. So 2 feet is really 24 inches. Okay, so let's explain it again. We couldn't just do 8 times 12 to begin with because it said cubic feet. We had to make it just normal feet, so we had to undo the cube, and then we converted. So we undid the cube, converted, and now we need to redo the cube. Because if we read the problem, it doesn't say what volume in inches is equivalent to 8 feet. It says cubic inches and cubic feet. So our answer needs to be cubed. So we need to take 24 and cube it, and whatever number we get, that's going to be our answer. What do you get when you cube 24? Perfect. So the answer is D. Now, I'm with you. When I saw this question first period this morning, I thought this is not what I wanted to do on a Tuesday. But, Tuesday means that they pulled the question from either the Aspire, so you just took it on your last interim, or it might just be a general ACT question. I took the ACT, I don't know how many times Ms. Brister took it. I took it 5 times. I took that bad boy like nobody's business. She's crazy. I took it 5 times. I was getting a scholarship over my dead body. Well, I took it 5 times. If I had not finally gotten the number I wanted, I would have taken it 5 more. Like, I was determined. And I know at least on one of those times I saw a problem like this. Let's talk about what they could do in the future to make it different. Instead of saying volume, they could say area, which instead of being cubic inches, it would be squared inches and squared feet. So we wouldn't undo the cube, convert, and then redo the cube. Instead, we would undo the square, convert, and then redo the square. So there's potential to make it a little funkier. Okay, you have your notes from yesterday, and somehow mine have gone missing, as is life. Oh, there they are. We had just talked about that menu problem, and we were getting on to the bottom ones. While some of us are just now getting back to earth, let's talk about what vocab terms we need. So here is my plan. My plan is we're finishing up 7-2 today. I want to do 7-3 quickly tomorrow. We're actually going to do it with a fun match game. I mean, we're going to have to know, but we're also going to have a fun match game with 7-3. My plan is to do 7-3, then review on Thursday, and test on 7-1 to 7-3 on Friday, which sounds scary, but it's very feasible if we remember what we're supposed to remember. So there were 3 vocab terms you were supposed to remember in 7-1. What are the 3 vocab terms? Ratio, which is a fancy way of saying a fraction.
Scale factor and postulate.
Scale factor and proportion. And then proportion. Which proportion was like fraction equals a fraction. So those were the 3 main things we learned in 7-1. This is a quick review of the words from 7-1. The 7-1 problems, either you set up a ratio, like 4 girls to 7 boys, or we had to do a lot of cross multiplying with portions, or there were some scale factor problems, and they involved like real life miniature models. For instance, I keep referencing my tiny Eiffel Tower. Going from my tiny Eiffel Tower to the real life Eiffel Tower, how would we convert between the 2? We want to keep the dimensions relatively the same. We just got to change the sizes. Okay, so those were the 7-1 words. If you've got those down, which most of us do, the only issue with 7-1 is sadly it's going to be a bunch of word problems, but you can probably figure it out. 7-2, yesterday we started talking about similar polygons. Similar polygons. Do you remember, if I cover that up, what makes something similar? What do they have that's exactly the same? The angles have to match. So the first thing I look at, any problem, is do all the rainbows match? Or do all the numbers match? I love a rainbow match. If they don't, stop. The problems we do today and the worksheet from today, they're all going to match. But keep in mind, if they don't, you stop and say, no, not similar. And I would be that person that put that trick one on there. That is me. Okay, and then the next thing says, similar have corresponding side lengths proportional. Which sounds crazy, but we talked yesterday about how you compare each side, like left side, top side, right side, bottom side. And every time we compared them, we kept getting the same number over and over and over again. And we called that number our scale factor. Yes, dear? Yes, dear. So if there were things I wanted you to remember from yesterday, one would definitely be how were we calculating the scale factor. And the second would be how to write a similarity statement. We talked about, like with a triangle congruent statement, the order matters. So for instance, in this example, A goes with R. The order of the letters matter. You've written things like this before, you're going to have to again. The order matters. So we did the example on the top with 10, and I made an awful joke. And we talked about how since we didn't have the same scale factor here, they weren't going to be similar. But since we had the same scale factor here, they were going to be similar. Does anyone have any questions after looking back over that up to where we are today? Okay. So our next 3, and we're only going to do 2 of them, say determine whether each pair of figures is similar. If so, write the similarity statement and the scale factor. If not, explain your reasoning. So we need to compare each of the sides. So if I do 6 with this triangle, what number do I need to use from the other triangle? 4. So I'm going to do 6 over 4, and that reduces to 3 over 2. Now, we talked about in 7-1, Will is going to lose 1 point if he doesn't reduce his fraction. Just 1, if it's a 7-1 kind of question. But, for what we're doing right now, if Will leaves it at 6 over 4, there's potential he could start to confuse himself. So just keep in mind, if you want to change it all to decimals when you're doing scale factor in this section, it's not a bad idea if you're not good at fractions. Okay. What do I do with 9?
6.
9 and 6. That also reduces to 3 over 2, and if you type that in your calculator, it's 1.5. And then last but not least, 10.5 over 7. And Savannah should have stopped me to begin with. Did all their angles match? Yes, they did, so okay, it was good to go. I guess she would have told me otherwise. 10.5 over 7. I don't know if that reduces to 3 over 2. I need to type that in my calculator and see if I get 1.5. Oh, you got 1.5. We got the same number each time. So if they ask us for the scale factor, I would say that's 1.5. Or you can put 3 over 2 if you'd rather do a fraction. And since we could determine a scale factor, we need to write a similarity statement. So if I say triangle ABC is similar to, what are the order of the letters from the second triangle? DEF. It's just like when we did triangle congruence. But you only get to write the similarity statement if you could find a scale factor.
So if you don't, you just can't say not similar.
Yes, not similar. I don't care if you put not possible, something like that. Yes, ma'am.
So for the second one, since it like
If you give away all my secrets right now, I'm going to be honest. You already know the answer to the question. Just hold it in and don't tell all my secrets. Okay. Are there any questions about number 1? Julianne's already on number 2, and that is the one we're going to work. But let's look at number 3. In number 3, if I did 6 from this triangle, what number would I need to use from the other triangle? 3, 6, or 4? 3, because it's between the 117 and the 36. We're not going with 6 and 4 because they're both on the bottom. No. We're going with 6 and 3 because of the angles they're in between. They're in between the same measured angles. So saying all that, that's what Julianne is wanting to look at on number 2. If I put 16 in the numerator, what number should I put in the denominator? Do I put 21? It would make sense. They're both top right.
24.
Why do I put 24?
Between the 1 and 2.
Yeah.
They're both between the 1 and 2 rainbows. So I do 16 over 24. They can twist the second shape to try to confuse you. 16 over 24 reduces to 2/3. Again, if you want to just type in the decimal, I think that's 0.67.
That's mean.
Well, they got to make it challenging somehow.
Well, is it always going to be if you did the larger number in the small triangle and the large number in the large triangle, that would go together?
Yes, it's always going to be the biggest numbers go together. So
The biggest numbers
16
go
and
together.
24 are always going to go together. The smallest numbers are always going to go together. The medium numbers are always going to go together. Brewster has another way to order it. You know me, I'm focused on the rainbows of the world, but she has another way. She's completely right. The biggest number in this triangle is 24. The biggest number in this triangle is 16. Duh, they go together. The smallest number in this triangle is 12. The smallest number is 18. So, of course, they're going to go together. But, you know, Miss Compton, when I looked at it, I saw 12 near the one rainbow. So I said it goes with 18 because 18 is near the one rainbow. You know I love me the rainbows. And then I said 14 was by the 2 rainbow and 21 is by the 2 rainbows. So that's why I said it's 2 over 3. But Brewster's completely correct as well. We could do either way. Me and her are both getting 100 today. My scale factor is 2/3.
Miss Compton, can we
Ma'am.
have Ryan Field to check out, please?
Yes, ma'am.
Thank you.
Or if you want to do the decimal, I think it's 0.67. It's like 6 repeating, so 67. And then since we found that same number over and over again, they are similar triangles, and I need to write my similarity statement. Would someone like to take a shot at that? Juliana.
ABC is equal to UGT.
Okay, she's like me. You know I like ABC order, so I would have done A, B, C. A was a 1 rainbow. The other 1 rainbow would be U. B was a 2 rainbow, so it goes with B, and then T. UVT. She is correct. Are there any questions about this? Okay, well then so far, I've handed you a worksheet. So far, good gravy. You for sure know how to do number 1 and number 2. You just wish I would show you 3, 4, 5, and 6 quickly. You just wish I would show you those quickly. So if you look at the front of the page the worksheet's on,
I need that worksheet.
you don't have one. I didn't have you one.
I didn't
Oh, okay.
Thank you.
Well, looking at the front of this one now, I blew this. If we're telling all the truth, I'll tell you the whole truth. I blew this first period yesterday. So I had to say, guys, let's start back over again today. Because I was not using my brain. I tried to say that X was equal to 3. But that's not necessarily true. Are these two
Similar
shapes the
to
same
3.
size? Yeah, they're not the same size. So instead, we're going to make it easy. I'm going to make 2 steps. My first step is going to be, can you find the scale factor? Can you find the scale factor? And in order to find the scale factor, you're going to need 2 sides with numbers. Do we have 2 sides that are similar to each other that have numbers?
A, B, and R.
Okay, and what numbers do they have?
6 and 4.
So 6 and 4. Now you can leave it at 6 over 4 if you want to. You know, I want to reduce it to 3 over 2. But if Will leaves it at 6 over 4, he's still going to end up at the right answer. Okay, so I told you there were 2 steps. That's not a lot. The second step is, can we set up a proportion? In our proportion, we're going to use the scale factor, and then we're going to set it equal to, and then I need to make some sort of a fraction using X and whatever side is supposed to be similar to X.
3.
So I will do X over 3. So again, I used my scale factor, and then I started solving for what I wanted to solve for, X over 3. And now suddenly all that section 1 stuff is useful, because you know what we're going to do. We're going to cross multiply and solve for X.
Do we only solve for the first one? Do we only solve one of them to find the scale factor?
Yes, yes. Once you find the scale factor, it's the scale factor for the whole figure.
Okay.
When I cross multiply, I get 9 equals 2x. So 9 over 2 equals x. Or if you want to put 4.5, that does not hurt my feelings. Any of them will do. I do not care today. Okay, so I found x. It's 4.5. And Miss Compton said there were only 2 steps. But is Miss Compton actually done? No, I haven't found y. So I'm going to repeat. I'm going to do step 2 again and set up another proportion. I'm still going to use my scale factor 3 over 2, which is what Natalie was wanting to know. But instead, I'm going to do what over what?
Y plus 1 over 8.
Is it y plus 1 over 8 or 8 over y plus 1?
8.
Yes, because we kept doing the left figure and then the right figure, so we've got to be consistent. If Will swaps it up, he's not being consistent. He's going to get the wrong answer. Okay, and then when we cross multiply, I get 3 times y plus 1 equals 2 times 8.
3y plus 3 is equal
2.
60.
Okay, and so 3y is equal to
Whatever 2 times 8 is.
16. It was 16. So 3y equals to
Wait, what
13.
did you do? 3y plus 3?
Yes, I did 3y plus 3 equal to 16. And I subtracted 3 from both sides. I'm just out of room, so I couldn't write it. So 3y equals 13. So y equals what?
13 over 3.
13 over 3, and if you want to give me that decimal, that's fine.
4.33.
4.33. What was the third one?
A lot of 3s.
Okay, 4.333. We're going to leave it there. Whatever. That looks good. Are there any questions about that one?
Yeah. What? Why didn't your first proportion work?
It did. I solved for x. I did 6 over 4, got the scale factor. And then I did x over 3, solve for x. And then I did 8 over y plus 1 and solve for y. I had to do it twice because there were 2 different variables. On this next problem, there's only the one variable, like number 5 only has one variable. So I'm only going to have to do a proportion once. It just depends how many variables are there.
What if there's not a y?
If they want you
You
to
only
find,
do it once.
if they want you to find whether they're similar, that's when you have to compare everything.
Yes.
But if they want you just to find X and Y, or any other thing, that's when you have to find the skill factor and figure it out.
Yes. Brister's noticing the words that I should have pointed out to begin with. And these examples, we're assuming already. We're told they're similar, and we're supposed to solve. We're told 2 polygons are similar. Now let's solve.
It just says front page.
Okay.
Yeah.
So let's look at 4, 5, and 6. Again, they tell us already these shapes are similar. So that means there already is a scale factor. What is the scale factor on this first one? Can someone who did it reverse tell me?
Is it like 10 over 5?
Okay, I did 10 over 5. It's okay if you did one, as long as you stay consistent with you, that's fine. And I said that's 2 over 1, and there's a reason I'm doing that one. I get 2 over 1 is just the number 2, but I told you there are 2 steps I'm doing right now. A scale factor, and then a proportion. And if I don't have a fraction, it's going to be hard to cross multiply.
So do you just keep it as 2 over 1?
I sure do. I'm going to leave it as 2 over 1 and set it equal to whatever it is I need to be equal to.
4.5 and 2.5.
Is it 4.5 over 2.5?
No, it's X or
Yes, we have to do 4.5 and X. They're both between the 1 and 2 rainbows.
Oh my God.
When you cross multiply,
How do you know which one goes on top, though?
it doesn't matter if you want to do what Kaylee was doing and she did 5 over 10 and then X over 4.5. Do now. You want another one? Are you asking me, can you do it reverse? Can you do this over this?
No, I'm asking, is it okay to switch X and 4.5?
No, well, if I did 10 in the top, then don't I need to do 4.5 in the top? Aren't they from the same shape? If I'm putting the big shape in the top in this fraction, I need to make sure the big shape's in the top in this fraction as well.
Okay.
Okay, so if I cross multiply, I get 2x equals 4.5, so x equals 2.25?
Yes.
Great. And then now we get to the next one. Why don't you take a second and solve the next one with your group? Make sure we're on the same page. We'll go over the answer in just a second, but I feel like Ms. Compton's doing it, and I need to know for sure you can. So you do it, and then we'll talk about what the answer is. Here. Yes. If you can figure out what the scale factor is to begin with, like, for instance, if you notice that 18 times 2 is 40, 18 times 2 is 36, but 30 times 2 is not 40, so
Well,
you know, splits in every time.
Sure, you have to use new numbers on both of them.
Well, I know this plus this plus this, but 18 plus 10, we don't know what that side is yet, and we don't know this side.
Oh, 40
You're
or
assuming.
30.
the fact that you see,
Reduce that, what's going to be?
I add 2 to it. So that should get 128.
Yeah, you're right.
No.
No.
I just don't want to try to do it, it's not going to work.
To put 4 over.
Okay, talk to your group. What did they get for the scale factor? What did they get for the scale factor?
Over.
What did they get for their proportion?
It's X plus 15.
Yes, help your group.
Well, I don't know if I did it right in the first place, so.
Don't you get it?
Yes.
All right.
My only issue is when they're cross multiplying.
So
It's
it's not
equal
right.
to.
This stuff's not right. This was right. So 72 should be 3x plus 45 equals 72.
All right.
Sure do.
Subtract 45.
Kaylee, does your group know the scale factor? Can you tell me? Okay. And then when you solve for x, what did y'all get? Okay. Kathy, did your group, what did you get for the final answer? X equals what?
I'm almost done.
Okay. Dylan?
Hold on.
Okay.
We're done.
What did you get?
X equals 9.
Okay, so everyone else is getting x equals 9. Let's talk about how we got it. I know some are still finishing it up.
For the scale factor?
No, she said 4 over 3. Okay, so I get the scale factor is 40 over 30, and I know that reduces to 4 over 3. Good on that. I mean, everyone seemed to have that. The issue is the next step, which is the proportion. I do 4 over 3 equals x plus 15 over 18. Now let me talk about Will because he won't mind. Will had the scale factor. So if we said this problem was 4 points, Will's getting 2 points because he found the scale factor. He's getting his third point for setting up the proportion. So he's 3 out of 4. He's going to get that last point if he solves for x correctly. But he had a tiny issue when he cross multiplied, and it blew it. There are going to be other questions where I test Will's ability to cross multiply. This section I'm really wanting to see, could he set up a proportion on his own? So if he can't solve for x, again, he's only missing out on 1 point. You cross multiply, you get 72 equals 3 times x plus 15. 72 equals 3x plus 45. So 27 equals 3x. So 9 equals x. 4 times 18. And then 3 times x plus 15. Still multiplying on those diagonals. Okay. Yes, dear? Number 6 is the doozy. So far we're good. Any questions about this? So if I were to look at the back of your notes right now, Juliana can solve 1 through 5. She just needs me to help her with number 6 on the worksheet right now. She doesn't know how to do number 6. Guess what? Example 6 and number 6 go together. So if I were you, on number 6, I would put C, example 6. They go together. That's why they're both 6.
Oh, that's smart.
Flip over your notes. Put C, example 6 on number 6.
What is that?
Okay, so let's look. Brianna, why are you stuck on this one? What's wrong?
Because they're all X's.
Oh my goodness. Brianna said she looked at number 6 on the examples, and we have a problem because she can't figure out the scale factor because every single thing in this trapezoid, every single thing in this polygon has X's in it. So she has a problem. She can't figure out the scale factor. Guess what? It's okay. She can still move on to step 2. Can she still set up a proportion? So let's see if she can. If I use 3x plus 1, what number do I need to use from the other? Do I use 8 or do I use 20? 20. So 3x plus 1 over 20 equals, and I'm going to do x plus 1 over 8.
We can do 8 over x plus 1.
Can you? If I did this shape in the top and then that shape in the bottom, then on my next fraction I need to do this shape in the top and that shape in the bottom. If you mix and match how you want to, it's not going to work out for you. I liked this one in the top. I leave everything with that left shape in the top. Yes, Dylan, if you want all yours to look like 20 over 3x plus 1 equals 8 over x plus 1, then you'll get the same answer. It's when you start mixing and matching that we have an issue. Either this shape's in the bottom or this shape's in the top. Regardless, the shape has to be together. Okay, when we cross multiply, we get 8 times 3x plus 1 equals 20 times x plus 1. I know you know how to distribute and solve.
24x plus 8.
Oh, we'll keep going then. 24x plus 8 equals 20x plus 20. Subtract 20. Flying. Let me see if I can beat you. No. Ah, so funny. Then do the other side. Okay, I ended up getting x equals 3. But again, if this problem's worth 4 points, heck, Brianna's getting most of her points for could she set up the proportion. Could she set up the proportion? If she does nothing, she gets a -4. If she at least sets up the proportion and it's correct, with the top shape in the same spot,
This is easy.
then she's going to get 3 out of her full points regardless.
Speak for yourselves.
Then flip to the back. And that worksheet is yours. I do not care if you work with your group. I do have one tiny blessing for you in that, yay! You'll know if you got it right or wrong, there's a key here. But at the same time, I swear if Dylan just has 7 written on number 4, I'm not giving Dylan his points today. He needs to have some work. I know. Since you leave me